Solve the system of equations below for x and y. Write your solutions in the form x comma y, then graph the system of equations, with your graphing calculator. So, reminder that the methods for solving system of equations are substitution, elimination, and equal values method. Since both of these equations are in y equals form, we're going to use that equal values method where you're making one equation equal to the other. So we're going to have 1 over x is equal to 2x plus 1. Then we're going to solve for x. I noticed this fraction, so right away I want to use my fraction buster strategy where we try to undo the dividing by x by multiplying every single term by x times x and times x. The times x and the divided by x cancel out, so we've got 1 equals 2x multiplied by another x is x squared. So we've got 2x squared plus 1x. Now, whenever I see that x squared, I think, oh, this is a quadratic. I have to make it equal to 0 before I start solving. So I'm going to minus 1 on both sides. So we get 0 equals 2x squared plus 1x minus 1. And now I can use any solving strategy of my choice. Quadratic formula, complete the square, or factoring. I prefer factoring, and I'm going to skip talking through it and just put the work on. So we need numbers that multiply to -2, but add to 1, and so that would be 2x and minus 1x. And so we've got a 2x by x, a -1 and a 1. So our factoring looks like 2x minus 1 multiplied by x plus 1. And since our equation was now equal to 0, we're going to use that 0 product property. So we get x equals -1 and x equals positive 1/2, because we're thinking about that we would need to get the x by itself. We would need to add the 1 and then divide by the 2 to get to 0. These are the x coordinates, but we did not follow the directions yet and find both x and y and write them in coordinate form. So our final answer is going to be a coordinate of 1/2 comma something and -1 comma something. And the way that I find those y coordinates is I go back to the original equation and I plug in my answer for x to calculate what the y coordinates would be. So in both equations I can plug in 1/2 as the x and in both cases I get that y would equal 2. So I know with my 1/2, the y coordinate is 2. And then with x of -1, same thing. I'm going to go back to my original equations and plug in that the x is a -1. It won't let me erase it, so we'll just put -1 and -1. We should get -1 in both situations. So we know that our y coordinate is -1. These are our two coordinates as our answer. And a system of equations, what you solved for is the coordinates for the point of intersection. So if we had a graph, I have this graph memorized, but you would need a graphing calculator. The first equation, 1 over x, is called an inverse graph. And it has these two sections that never touch 0, because you can't divide by 0. And then the 2x plus 1, that's a linear line. The y-intercept of 1 and a slope of 2, something like this. And so we can see those 2 points of intersection that we found when we solved the equation. Plus, let's look at one more example. Find the intersection for the two functions below, and then graph the system to confirm your solution. So again, both equations are in y equals form, so we can make them equal to each other, called equal values. We've got x plus 1 equals x squared plus 4x plus 5. Because of that x squared, it's called a quadratic, so I need to start getting everything equal to 0. So I'm going to minus x on both sides and minus 1 on both sides. We have 0 equals x squared plus 3x plus 4. You can use quadratic formula or factoring or complete the square. I'm going to use complete the square only because it's a test topic and I want to make sure that you're comfortable with that skill. So I'm going to start by making a square. I put x squared in. Then I have to take this middle term and cut it in half, so that half goes into each side of my square. So 3 cut in half is 1.5. So I'll have 1.5x in each side of my square. And so this will be an x by 1.5. So my answer is going to look like x plus 1.5 squared. And then we need to find out how much more do we need to add on or subtract to get back to our original equation we started with. So we're going to take the 1.5 times 1.5, which is 2.25. And then we look at how does that 2.25 compare to the original 4? Well, to get all the way up to 4, we would need to add 1.75 back on. And then our original equation, now that we're trying to solve, was equal to 0. I missed the squared. This process was complete the square, but we still need to solve for x. So to continue completing the square, we would have to solve for x, we'd have to minus the 1.75 on both sides. Negative 1.75 is equal to x plus 1.5 squared. To undo the squared, we would do the square root on both sides. And, oh, we end up with the square root of a negative. That would be no real solution. That means our solution is an imaginary answer. We could find the imaginary answer, but it doesn't help us in a system of equations because it's telling us that these two graphs do not intersect. So if we tried to graph them, x plus 1 would be a slope of 1 and a y-intercept of 1. And then the x squared plus 4x plus 5, that's a parabola or a U-shaped quadratic, and it's about like this. And the two graphs do not intersect. So in this case, we would say that there is no solution, no coordinates as the answers.